Our next speaker is John Takakawa, and John's talk is entitled Estuary-Nearshore Climate Change Effects in Relationship to Migratory and Listed Species. John has been a research biologist for the federal government in California for 23 years. He's with USGS's Western Ecological Research Center, leading the San Francisco Bay Estuary Field Station. He has a BS in Wildlife Science from UW, a MS in Wildlife Resources from the University of Idaho, and a PhD in Animal Ecology from Iowa State University. Iowa State, they're not the Hawkeyes, the Cyclones. My bad. His research studies have focused on migratory water birds and their wetland habitats along the Pacific Rim, with a specialty of applications of telemetry to study movements and migration. Please join me in welcoming John.
Thanks, Lev. I'd first like to just acknowledge co-authors that didn't get on the program that really did a lot of the work that is shown here. Karen Thorne, Corey Overton, Mike Kazatza, Toby Romer, Nicole Athern, and Susan Dela Cruz helped a lot with some of the data you're about to see. And what I'd like to talk about, primarily some initial work that we're doing underneath the relatively new USGS climate change program and the National Climate Change and Wildlife Center, of which we were awarded one of the 7 grants in the country last year, to look at estuarine wildlife with respect to climate change and the details of what we should be concerned about in these species. So we've had help underneath the USGS from this program, but we have lots of other partners where data are contributed from things we've already studied to go into this approach of can we take a better look at species concerns relative to estuarine and nearshore species. I'm going to focus mainly on estuarine species in this topic. And in fact, what I'm trying to focus on is that global climate change models give you a broad scope of what climate change may do. The ecosystem response slowly filters it down toward like the region of San Francisco Bay, and the regional habitat response might be an area within San Francisco Bay, and then habitat requirements might be a particular refuge, a parcel, an area where a species has to deal with the changes that are caused by climate change effects. So what I'll talk about are 2 types of habitats in the estuary, shoal habitats that migratory birds use to a great extent, and tidal marshes that are used by endemic species. So I'm going to go first and give you some of my interpretations of climate change issues in estuaries. And again, we all start from different viewpoints, and mine are pretty basic and remedial. I'm trying to learn from meetings like this on hearing Dan Kane and others about what things to be concerned about. But basically, the effect on estuaries will include sea level rise that is potentially going to inundate a lot of low areas that are unprotected by levees and possibly erode existing levees. So that is one of the main concerns that leads climate change work in estuaries. However, there also is the opposing effect of snowpack runoff decrease in the western U.S., where if snowpack runoff decreases, then there'll be less fresh water coming in from that source, and in fact that the timing will change on how that water comes into the system. Both effects which will have a great effect, we think, on resources and then on migratory birds. Another part of the change that will come from sea level rise, as well as this change in inflows, is we expect salinity to increase up estuary. And this is work from, again, Dan Kane, who spoke this morning, showing that in summer conditions that we're going to see a lot more of the orange color heading inland, where we expect to have higher salinity coming into the delta and in areas inland. So my assumptions, again, are that sea level rise will, and I'm using this from earlier papers, so again, the adjusted estimates that we keep hearing, we don't know where to start. I'm going to kind of work in the range of ½ meter to a meter in sea level rise. Some estimates indicate this will be inundating 39% of the intertidal habitats in the bay, 70% in the South Bay without levees. We expect water temperatures and salinity will increase. How that will increase will happen, we're not quite sure, but as far as that we expect that to happen. High and low tide events should become more extreme. 30 centimeter increase in models suggests that storm events will multiply by 10. In other words, a 100-year storm comes down to a 10-year storm that will happen. Western snowpack will be declining, so it already has decreased quite a bit since 1950, so we expect a lot less water coming in. Finally, because it's going to be earlier and shorter, we expect different pulses coming into the estuarine system. So first, shoals and migratory birds. I made a few assumptions about this. First, we believe that water depth is likely to increase over existing shoals, but it'll inundate the edge of the bay, the bathtub effect, as water levels rise from sea level rise. But the changes in salinity, temperature, and depth are likely to be ones that affect macroinverted communities that are resources for migratory birds. Now, the change varies with species mobility, and that is that we have local, regional, and continental migration. And all those species have different responses to what kind of resource use they have within the estuary. So one of the big concerns is whether migration routes and phenology of migration will actually be affected, and that's much harder to study than some of the in situ populations. We kind of go with the hypothesis that food abundance is one of the major limits. We just had a joint venture meeting yesterday for San Francisco Bay, and that is the premise of the joint ventures across the country. Food abundance in the winter for wintering populations, not breeding. Wintering populations like San Francisco Bay are limited by food abundance, and they're often driven by salinity, also temperature and depth, and a few other conditions. And this slide is just a reminder that it varies according to species what particular macroinvertebrate they're targeting for their prey. In the case of terns, it might be fish. But food availability is determined by water depth. So you're looking at this, you can see the array of different species that are smaller legged birds into the birds that dive into the water column. There'll be a different array of what species are found depending on how much water there is. So with sea level rise, we expect there might be a redistribution caused by the change in the water depth.